maybe you can stop sharing and again start sharing and just add your speaker.
Okay, so sorry for the interruption. So I hope you could able to hear me now. Okay, so sorry for the interruption. So I hope you could able to hear me now. Okay, so as we are seeing the electrical machine one, that is efficiency, and this one. So the question itself I am showing here, that is now what are the details they are asking. Just we need to have a look here. What are the details? He's asking the factor, means where is my maximum efficiency occurs. So OC test details always gives the open circuit losses, that is how much he has given, 64 watt, that is iron losses. And short circuit test losses you will get are the copper losses, but indirectly he has given 90% of the load. Here is the main crux. So we shall not take direct one, because the load factor at maximum efficiency we need to understand is that x is equal to root of full load, but here he has given only 90% thing. So the 90% to full load I need to bring it. So here we need to understand is that x square copper full load is whatever the actual value is there. So from here we can understand that copper at full load is 100 watts. This is the information we want it. If suppose what are the mistakes students do here are basically wi they have given, it is not depend on the load, but copper is dependent on the load. If you are taking directly 81, if you put here, there is a lot of big mistake, or you can feel it as a this big. So first of all what we need to do is 64 by 100, because this is the full value we need to draw. So that is 0.64, you will get it as a 80%, or 0.08 0.8 value will get it. Then you can understand that this is a 80% load. Now I hope you understood what are the crux he has given. It is that we need to understand the 90% value here, then accordingly you will get it. So if you have any other doubt, you please ask here, so that we can understand that what are the other points you are having, we can see it. Okay, so as we're seeing the electrical machine one, so shall we go to second question? Yes. So the second question is showing here are the second question we can see here. So sorry for small disturbances. So we'll now onwards the compatibility to the system we can make it. I hope you understood. Now onwards, not only the question and answers, but if any concepts you want to repeat me, you just ask that one, so that I can see those concepts point of view also, so that I can clarify not only questions. Now, a 4-pole induction motor supplied by the slight unbalanced 3-phase 50 Hz source is rotating at 1440 rpm. So has given the speed and frequency. The electric frequency in Hz of the induced negative sequence current of the rotor. So this is a question he has given. Now the second question, the data. So I hope if anyone, whatever the answer you got it, you just try it, so that what are the crux we can easily find it. Someone can try. I'll wait. Now see, if anyone is asking the frequency of the rotor, automatically everyone knows that it is a slip into supply frequency. This much we know it. But the question is a little bit crux. They made it as negative sequence. So to understand the concept, we need to know that what are the positive sequence, what is the negative sequence. Always you see it, the supply is having my phase sequence of, take an example RYB. If I'm taking some phase sequence RYB, if my induced EMF or induced rotating magnetic field, whatever the concept we see, if it is following the same supply, then we can call it as a positive. If it is following the reverse one, then we call it as a negative sequence. So here the induction machine concept we need to understand is that if stator RMF is rotating in this side, due to the induction, the rotor will rotate in the same direction, so that the relative speed can be reduced. So here when you are seeing it, normally this is the rotor frequency we feel, but here the question he's asking is negative sequence, means the frequency of the reverse direction. If the same rotor is rotating in a reverse direction, at what speed? So as we are seeing that there is a direct formula, 2 minus s into f. So first of all we need to find the slip. What is slip? Ns minus nr by s. So that is whatever we are having, we need to find out it 0.04. That is, we need to find here 2 minus s into f. Can you note down? Can you give the answer? So always, if negative sequence means the rotor is taking into the negative, then accordingly. So answer is 2 minus 0.04 into frequency is 50. The answer you will get are 96, 98H. Sorry. Can we move on to third question? Yes. For a specified input voltage and frequency, if the equivalent radius of the core of a transformer is reduced by half, the factor by which the number of turns in the primary should change to maintain the same no load current. So the formula we need to understand is that here the relation between the radius, so radius is reduced, then I want to maintain the same no load current. So how many number of turns I need to? So what is the relation with the radius to core and to the no load current? So internally when you are seeing it, this is a magnetic concept totally. So what are the magnetic points we need to remember here are the magnetic points. When we see immediately, you, whenever electrical concepts whichever you are coming, just imagine the things, don't just by heart, and if you are having the formula you can do it, but you need to understand the concept by the imagination. For the specified input voltage and frequency means voltage and frequency, specified voltage and frequency, that is for sure. If the equivalent radius of the core of a transformer is reduced by half, means the radius, whichever the radius is having, that is reduced by half, then the factor by which the number of turns in the primary should change to maintain the same no load current. So especially when you're talking about no load current terminology, especially it depends upon the voltage because the terms. So always whenever if I'm changing the core, one more important factor always we need to see here in the transformer is a flux. That is a, it is related to the reluctance, the path. So the core radius and the reluctance are the inverse proportion. So if you made into half means radius, the reluctance, that is a big capital R, it becomes twice. So the, and what is the thing, because no load current I want to maintain the constant, means reluctance is double means mere flux is reduced by, so to increase my equal number, then automatically what I need to do, because n into 5 relation I want to maintain the constant, so the 5 is off, so that 2 times of the turns I need to maintain. So the answer is double the turns. Okay. Anyone has any doubt, you can use the live chat in the YouTube so that we can follow you. Are there any other doubts you are having on the this type of the concepts? You can ask, not only with related with only this question, any of the concept. So the answer is C. Sorry, answer is C. Hmm. Hmm. The core loss of a single phase 230 by 115 volts 50 Hz power transformer is measured from 230 side by feeding the primary 230 volts from the variable voltage variable frequency source while keeping the secondary open circuit. So this is a open circuit they are doing. HV is energized, LV is open circuited. This is a simple thing we understood. Now what is the question he is giving? The core loss is measured to be 1050 watt for 230 volts 50 H. So he is following the standard thing because open circuit test has to conduct at V rated and F rated. So they have done it. The core losses is again measured to be 500 watts for 138 volt 30 H. So here the again they changed the parameters. The hysteresis and eddy current losses of the transformer for 230 volts 50 H input are respectively. Now here we need to understand what are the formulas related to voltage and frequency relation. Always whenever we are talking about the transformer, the flux must be constant. That is the relation is voltage by frequency. But by the operation here I am getting a two relations. Either V by F is constant relation or V by F is not constant relation. So what are the relations we can understand here? If suppose V by F is constant, what type of the relation? If V by F is not constant, what type of the relation? Here when we are seeing the relation is hysteresis loss and eddy current losses when we are talking about. So if V by F is constant, then automatically the relation is coming up. The new hysteresis loss is directly proportional to frequency. That is, if V by F is not constant, then what is the relation? So V by F is constant. This type relation we can see it as a F square. But here V by F is not constant. That time we need to derive the relation. You will get the relation type. Now we need to check what is the question he has given. First thing he has given is V by F, that is 230 by 50, and another relation is 138 by 30. Is a voltage by frequency relation is same? Is the voltage by frequency relation is same? So what I am getting is V by F relation is constant. If you know this relation, then we can proceed further. So we know that what is the iron loss? Iron loss is both by mixing both these. So iron loss is hysteresis loss plus eddy current losses. So the iron losses are WH plus WE. So now here what is the formula we will get? That is AF plus BF square. So first of all, at F is equal to 50. So what is the value? We will get the value is 1050. That is A into 50 plus B into 50 square. Next WI F is 30. What you are getting the value? That is 500. Here is A 30 plus B 30 square. If you are doing that, it creates a big mess because you need to do the big calculation. So the shortcut is take the 50 common. So obviously A plus B 50. Next is 500 by 30, A plus B 30. So from here you will get the B value. I hope students you can do what are the B values and what is the A value. Now then he is asking the question, is that hysteresis and eddy current losses of the for 230 volts 50 Hz input. So he want the separate values. So the same thing, that is at this one only he is asking. So 1050 the total. So one more thing we need to understand, at what are the values. So here if you do the sum, whichever the sum is giving the 1050, that is the answer. So then another way or shortcut way is that how to get the 1050 automatically. If you see it, 508 542, so it is also it is giving, and 468 582 552, so all are giving. So by seeing the simple shortcut you are not getting, so this logic you eliminate. Normally what one more session is that sometimes by seeing the answers itself you can eliminate, and by some observations logic we can create it, but here both are 1050 only. So what is the answer you are getting? Kindly reply whatever the answer you are getting. That is 0.217, A is 10.167. So 1050 I want to get it, that is A into 50, that is you will get it as a whatever the answer is 508 watt. So one it is you are getting means automatically second one. So 508 and B is this much. So B 50 square, that is 0.217. It will give the 542. So answer is mm, mm. I hope you are following me. I'm not going very fast. Mm. Now, okay. Now, I'm I'm expecting answers from you, whoever is watching. Okay. For a single phase, two winding transformer, the supply frequency and voltage are both increased by 10%. This is a very good experimental type of question. Now we can see it. The percentage changes in the hysteresis and eddy current losses respectively. For a single phase, two winding transformer, the supply frequency and voltage are both increased by 10%. The percentage changes in the hysteresis loss and eddy current loss respectively. Anyone? Just post your answers. Abhishek. Hmm. Initially, he has given voltage and frequency are increased, both increased by 10%. So indirectly, the logic is V by F is constant. So if this is a relation, what is the relation with the hysteresis loss and eddy current loss? Hysteresis loss relation is A into F. Hysteresis loss is relation is V into F square. So here V by F is constant relation. There is no link with the voltage, but the voltage and frequency relation I need to decide which case it is coming up. So the frequency increased by 10%. So the hysteresis loss is increased by 10%, and eddy current losses, that is, so suppose the frequency you are taking it as 100 earlier. If it is increased by 10% means 110. So 110 square. So basically 1.21. So when you are seeing the relation, because 11 is a basically when you are talking about 1.1 square, if you are seeing it 1.21. So earlier value is 100, present value is 110, but my eddy current losses are presently when you're talking about 100, I will get it as this much, and this one is this much. So how much percentage it will come up? 21%. So this relation not only in the transformer, but in the same induction machines also you need to follow the same relation. Sometimes if frequency changes, what is the torque relation they will ask. That time also the same relations you need to work. Wherever my terminology is there, if it is a F is a 10, this is the suppose one more question they will ask. Take an example. Here it is increased. Take an example. One more logic I want to give. Suppose frequency reduced by 10%. Frequency reduced by 10%. Then how much percent of eddy current losses reduces? Just think of it. If 10% increased, 21% increased. If 10% reduced, how much percentage it will reduce? This is a way of questions we need to look at whenever we are seeing about the questions. As we are doing the practice, this is a way. As I'm the faculty, so normally if you are asking me the question, if I teach increase, but in the question paper I'll give the reduction or decrease. So that's the way the students also think about. So what is happening here? The 10% decrease means what is happening? 0.9. So this is 0.81. That is 19% reduction. So that's the way we need to see at F square, F, and sometimes F cube relation, sometimes speed cube. In induction machine, normally this type of the problem we will used to get in the topic. In the same this one. So if the 10% is increased, the eddy current increased by 21%. But if the 10% is reduced, the eddy current reduced by 19%. I hope you understood the logic. Here it is same 10% increase in 10 because it is a directly proportional. We won't change the value. Now, sixth question. An open circuit test is performed on 50 Hz transformer using variable frequency source and keeping V by F ratio constant. To separate its eddy current and hysteresis losses, the variation of core loss frequency as function of frequency is shown in the figure. So this is the figure he has given. So what is the question he's asking? At the end he's asking at 25 Hz. So you might be knowing this type of the problem normally we do, or this test normally we do to separate the constant losses from the. So here, because even the if load is frequency changing, my eddy current losses and hysteresis loss are changing, but I want to separate the constant losses with the variable thing within the eddy and hysteresis losses, that is the no load losses. So that is the important concept here. How to. Sixth question. Sixth question. So the 25H, 50H. So open circuit conductor at 50H at variable frequency source, keeping V by F ratio constant. Now my case I already understood. If it is a V by F case, V by F is constant case. So if V by F is constant, then to separate eddy and hysteresis losses, the variation of core losses and frequency as function of frequency. So that is the point when you are seeing it. Always you see it. This is a equation point of view, and here what is the rho value he has given? That is a P by F, and this is a F value. So wherever the point is there, so this equation you know it, constant and MC, that is M is the slope. The same way the P by F equation is A plus BF. A plus BF. This is a V by F constant case we understood. That is P is equal to A into F plus B into F square. This I understood it as a, if I take common, this is the equation I got it. So this is a initial value, that is Y is equal to mx plus c type of the formula. If this is a constant, this is a 1. This is a m means slope. So whatever the value it here, the m slope is basically B. So B value is the slope and frequency. So here we can easily find what are the values it is showing here. So obviously A is, what is the value? You can chart. A is what is the A? So the A value is 10 and P value we need to take it. So some value, whichever the value you are taking, you just take that one. So that is whatever the value it is there, we can take it. So basically B is a tan theta formula. So tan theta when you are taking up 5 by 50, so at 50 when you are taking up, then you will get the 0.1. So we got the slope, this. So now he's asking the total loss. P is equal to A into which frequency is asking, at 25H plus B into 25 square. So A is 10 into 225 plus B is 0.1 5 square. So basically what is the what are the values we will get? It is 250 watt and 62 point. 250, 62 point. So we need to take the slope. So this is a text normally we do is the separation of the fixed losses or constant losses in the no load losses. So answer is Answer is any doubt? Can we try for the next one? This is auto transformer only. Next one, can we try? This is auto transformer only. What's the question? A simple one. Normally the question only they give, but they have given the total diagram also. A single phase 50 kVA, that is transformer is 50 kVA, 1000 by 100 volts, two winding transformer is connected as an auto transformer as shown in the figure. The kVA rating of the auto transformer. So here the difference and auto transformer advantage we can see here. Auto transformer. What is the question? He has given that 50 kVA, 1000 volts by 100 volts. So in our class normally we do the 4 type of the problems here. So here the question itself he has given the voltages, the diagram we need to see here. So the diagram itself he gave it as a additive type. So and he already told 100,000. So total voltage is 11 and here the input voltage is 1000. This much he has given. But what is the current? So current concept we need to understand. He has given the rating. So in the two winding transformer, by doing the problem we need to understand the current. This is 1000, this is 100, 50 kVA. Okay, so how much current it will flow here? Here it will flow 50 amps, that is 1000 volts. Here the current directions are like this, and here the current 100 and here the current flows is 500. So first of all we need to understand how much current. So in the 1000 winding the current, here when you are seeing it, the current is 50. In the 100 winding, because it is living, so how much? 500, that is coming here 500. So total is 550. So this is 550 into 1000. So if you are seeing the primary side of auto transformer both sides kVA rating also is constant. Okay, so primary, that is 550 into 1000. When you are seeing it is a 550 kVA. If secondary auto transformer is into current is 500, that also 5. So this is the way we understand and solve the problem. Any doubt? Any of the point you want to see here? And here I want to share the shortcut is the S auto, that is kVA rating of auto is equal to A by A minus 1 into two winding transformer. So when you are seeing it, normally A must be greater than 1. So here, how much KV rating we need to understand. So what is A here? A is how much? How much is the voltage we are taking up? A is a greater than 1. So in this concept, when you're coming up, that is A is by 1000. What you will get? 1.1. So 1.1 by 1.1 minus 1, that is 1.1 by 0.1. That is at the end you will get it as 11. So 50, 550. This is a problematic side or formula side. Two ways, either by connection, either by formula. This is most useful whichever the connection is there. But always remember A is greater than 1. So whatever the higher voltage of the auto transformer, this is not the two winding transformer. Whatever the highest voltage is there, that one, and least side voltage. So same example, if I am doing with, take example, the same connection, same two winding transformer, 50 kVA, 1000 and 100. But auto transformer connection I am changing. I am taking this side is 101 and this side is 1001 and this is 101. So for your case, I am taking it is a both are ready to only take example. This is 1100, this is 100. Okay, whichever it is, you take it as a, you don't take this much as this one and you take this one, whatever it is. So this is up to the connection, but sometimes to find the winding side, it gives a little bit understanding point of view. So here when you are seeing it, what is the point is, here A is 1100 by, what is that, 1100 by 100. So you will get 11. So yes, auto transformer is equal to A by A minus 1 S two winding transformer. That is 11 by 11 minus 1 into S two winding transformer. That is 1.1 into 2 winding. So the same transformer, if the common winding is 1000, you are getting the 550. If the common winding is 100, if common winding is 100, you will be getting 1.1 into 50. How much you will get? 55. So many times there is a point, always people say that, sir, if you are converting from two winding transformer to auto transformer, you will get always 10 times of the rating, all this logics. But there are a few conditions to be satisfied whenever we are converting the two winding transformer to auto transformer. That is, the first condition is that whatever the common winding is there, that is the maximum terms shall be common. Maximum terms shall be common. And the second important is that the connection shall be additive. It's not a subtractive. Suppose if I'm taking this one as to here, this is a subtractive type connection. That time I will get here 900. So these are the two conditions to satisfy. Then only the two winding transformer, if you convert into auto transformer, you will get 10 times of its rating. So that's why many times when you write the advantages of the two winding transformer to auto transformer, always we need to see that for the advantage purpose, if you are going the maximum turns and additive connection, it gives a good example. So I always suggest whichever the easiest way the students are feeling it in the exam hall, you do that one. So that's why always the one suggestion to I always give to students are, so always we need to see that one as, whenever always how the which type of the method we need to use it. That's why the practice comes into picture, because this type of the last minute revisions, when you're seeing it, different ideas you will get into. So it is good when you're seeing and you're getting the option to listen the classes, that you can do it. The most important thing always I suggest is that, suppose now presently the exam is on February 7th. So the exam is on February 7th, so that the 20 days or 25 days before, 25 days before, you close your preparation, and you close your preparation and do everyday mock test, online mock test, but don't use your calculator, online method only, no other option you shall have it. And especially when I'm seeking this type of the thing is, whenever we are seeing, take example, my exam is from the 2 to 5 p.m. Now this year is also, this is the time, so 2 to 5 p.m. So this time only every day, since because now it has time has been started, you need to start this type of the practice is that every day 2 to 5 you need to sit at your home, and you shall feel that you are giving the main exam, and seriously you need to give the exam. After 5 you verify, and you will get some marks, and you analyze yourself, what are your strong areas, what are your weak areas, especially the subjects, which subject I am most confused, where I am prone to make the mistakes, those things you need to. And the till night or next day morning, whichever the time, whatever the time you are fixing for, again you start preparation, whatever the subjects you are having, and you do analyze and new concepts, and again next day you sit for the exam, again analyze, so that in a day by day the strategies you need to change it. Strategies means you might be understanding. So now for auto transformer itself, what I am doing, I have a two ways of doing it. One is by connection diagram, one is by formula. Which one is easy to you, you follow it, no one will question you, but at the end of the day they need the answer. So the methodology which one you need to follow it to, you will get to know. And way of attending the paper, it's not that giving the paper, but way you need to understand. Way means, so take example for me, if I'm seeing it, all the 60 questions, everything, whatever the 100 marks questions is related to this, every question easy, every question I will question paper I will read it, easy questions I will tick mark, and little bit if I want to use some formulas, I will do take some time and I will do it too. But tough questions whichever I'm feeling, I will note on the separate rough paper and I will keep it. And within 1 hour I need to target this. So after next second hour, again whichever the questions I have answered, I need to look at this, and the tough questions I need to solve within 1 hour. So roughly roughly 1 hour 45 minutes I need to close this one, so I have 1 hour 15 minutes in my hand. Again I will revise. So what are the questions are 2 hours, if it is there only 1 hour it is revising. So last 15 minutes I will take it as a recheck all my answers, because earlier when you are answering the simple questions, you feel that okay this might be the reason, but after solving all these things you will keep on looking at, hey yes, there might be some small mistakes you would have happened, you can rectify it. These are the practice. When I was doing the practice, so that time I realized that when I revise the paper I'll get a more comfortable answers and I can do it. So this is the most important. So whatever the timings you are having for the exam, please go on, and especially this is a last minute revision will give a good support to you and gives a moral support and clarifications, you will get it. So this is the auto transformer concept. So normally four types of the models and auto transformer and other advantages, saving up the copper, all the things. So if you are seeing it, what type of the shortcut you can know it. In my classroom, normally I used to tell the shortcut is for the transformer is that. So when you're going for this, so we need to see that there is a table always I give to them. So the table just I want to give to you also. These are the concepts, and you need to multiply from auto transformer to this one. So just to note down, there are lot many shortcuts. We'll get it. The saving of the copper requirement. These are the questions we will get here. So how to solve this? We can see that. So just I'm giving the list. Just if anyone has any doubt, you can come up with that. Hmm. Sorry, I missed the page. Wait. Anyone, any doubts you are having? Just I'm seeing your views. If any doubts you are having. Okay, go on. So next question I'll post it, and meanwhile I'll give the question to you. This is a another question. So just I'm giving. So normally I give for the FLT for one of the year. Just I'm giving here. I'm not showing that question. Just to see here. A single phase 50 kVA 250 by 500 volts two winding transformer has an efficiency of 95% at full load. If it is reconfigured as a 500 by 750 volts auto transformer, what is the efficiency at rated load at unity power factor? He has given the auto transform connection, but he's asking the efficiency. No other details has been given. Just think of it. You do it. After that, I'll give the shortcut for all the auto transformer related small questions. How to solve this? Because just I remembered this question. I hope students are following. Hmm. Hmm. I hope you're getting the logic here. Mm. Okay. Any thoughts? Please post on the comments. Okay. Here, the logic we need to understand is that here he has given the 95% because we need to understand that here the crux is that the copper requirement, whichever the copper is there, that much only we have used. So first of all, by using the known equation, we need to know the unknown thing. So 50 by 50 plus loss, that is 0.95. So the total losses we will get is 2.631k because core is same, copper is same, no change. So as per this, the kVA, we need to understand what is the new kVA of the auto transformer. Auto transformer new kVA is A by A minus 1 into S 2 winding transformer. So 2 winding transformer kVA is 50. So this is 50 and A auto transformer A is 750 by 500. Okay. So 5, 15. So that is 1.5 by 0.5, 3 times. So 3 into 50. You will get is a 150 kVA. So my auto transformer rating is, that is, yes, a auto transformer I am getting is 150 kVA. Got it now? I already told high voltage to low voltage. So the transformer here, auto transformer rating he has already given 500 by 750. Always A is greater than 1. That is the logic we need to know it. So 150. So auto transformer efficiency is 150 by 150 plus 2.631. That is 98.276. Got it? Now, the auto transformer tips. Just I want to give here so that for you in a one page or one step you can remember auto transformer. So if you're taking K is a point of view, so K is a transformer, that is two winding transformer transformation ratio point of view. So the per unit short circuit current are divided by 1 by K and whatever the logics. Here there are different logics into K divided by 1 minus K and into 1 minus K. Hmm. What are the into K and into minus 1K? So basically the percentage 1 minus K, the points are always the kVA rating. This is the one more important, and per unit current. These are the unknown point. The per unit current of auto transformer is divided by 1 minus. So what is the relation we need to understand here is the relation is auto by 2 winding. Then this is the relation 1 by 1 minus K. So this is a relation I am talking about. S auto by S 2 winding is 1 by 1 minus K. S auto by S 2 winding is equal to 1 minus K. S auto by S 2 winding is equal to K. So these are the logics just I'm speaking here. So that is a conductance, conductive kVA, and here into it is we are talking about per unit impedance of auto transformer is per unit impedance, already we have seen. And per unit, when you are talking about the into 1 minus K logic, into 1 into 2 minus K also, into 1 minus K into 2, this logic also we see it is a F auto, that is mmf of auto, mmf of auto, and regulation. So that is into 1 minus K is the regulation, per unit impedance, full load losses, so that is per unit Z, per unit or all the logics, because per unit is the most important. I hope you understood. What is the conductive kVA of auto transformer is K into 2 winding transformer. What is the per unit current of auto transformer is 2 winding transformer by 1 minus K. And regulation of auto transformer is equal to 1 minus K of 2 winding transformer. These are the logics. Now just I'm coming to, just we will summarize the transformer topic. I'm moving into the 5th page in the question paper, whatever we have prepared for revision. Now this is a question. This is also related to auto transformer. Yes, a 200 by 400 volts 50H 2 winding transformer is rated at 20 kVA. So the 2 winding transformer on 20 kVA, its winding are connected as an auto transformer of rating how much, 200 by 600. A resistive load of 12 ohms is connected to a high voltage 600 volt side of the auto transformer. The value of equivalent load resistance as seen from low voltage side is. I hope first you draw the winding diagram, then you see the resistance. See the resistance. Just write, draw the winding diagram. Can I get answer in the chat room? What's the question number 18? Just nothing but, so what he has done, 200 600. So here he has connected 12 ohms. What is the primary? That is R2 dash. So R2 dash is equal to R2 into around, you will get 4 by 3, that is 1.33. So normally the value is near to 1.3 to 1.4. Basically this is answer. 1.3 to 1.4. So auto transformer is over. Now just I'm coming to transformers. Just we can complete the points. So two single phase transformers T1 and T2, each rated at 500 kVA, are operated in parallel. Percentage impedances of T1 and T2 are this one respectively. To share a load of 1000 kVA at 0.8 lagging power factor, the contribution of T2. Simply, this is a parallel operation. So, parallel operation, only one logic you remember is it's a networks in a parallel connection. Only two types of the networks only possible with you. This is my impedance because transformer I can represent with impedance Z1 and Z2, two connection. So the parallel condition operations and everything, everyone knows that because we need a same phase sequence and vector group shall be same and voltage shall be same and frequency connection of shall be same, all this same. But when you're coming to the problem, only two types of the problem because if the two parallel are connected and the load is single only. So the first one is 1, 2. So this one is because the voltages are not same, then the clause may come up. If voltages are not same, then clause may come up. But another case is two impedances, single load, just equivalent circuit, nothing. Don't worry about any other thing. So because both are connected, the transformers are identical and this. So this is a problem he has given in the 19th. So 19th what he has given, two single phase transformer T1 and T2, each rated 500 kVA, are operated in parallel. The percentage impedances of T1 and T2 are 1 plus J6 and 0.6 plus J0.48, 4.8 respectively, to share a load of 1000 kVA at 0.8 lagging power factor. So here he has given nothing, he has given, even though here ratings are also same, 500 kVA, 500 kVA. And what is the logic he has given? 1 plus J6 is 1, another one is a 0.8 plus J4.8. Okay, and load is 1000 kVA, 0.8 lagging power factor. The condition of T2. So basically the logic here we need to understand is 500 kVA, 500 kVA, 1000. There shall not be overload. But here the each Z per unit are same or not, we need to check it. The ratio is same, but values are different. 1:6. Here also 1:6. So R by X ratio is same. R by X ratio is same, but Z values are, Z per units are different. So Z value is different. So what is a Z per unit? Just to take an example, what is a Z per unit? Always remember. Now you treat this as a source and it is coming. So current division rule is a simple logic for the load sharing. Current division rule. Current division rule. So here I is coming, I1, I2. What you will do? What is asking how much load it will share. So I2 is basically what we will do. Total is 1000 into opposite by total, that is 1.8 plus J10.8. So in this logic you will get this is a way. Always remember, load sharing means current sharing. Current sharing means parallel network. Parallel network formula is same. Total current into opposite resistance by total resistance. Simple logic. So that is a way you solve the problem whichever it is coming up. So then the answer, because always you remember, whoever is having the less, that will be overloaded. Simple logic. So here 6 square plus 1 square, that is root of 37. Here when you are saying root of 5 or less, so this Z2 is less than Z1. So whoever is having a less impedance, the current is more. The same way, whoever is having a Z per unit is less, automatically the sharing is more. So it is more than 500. When you do the problem, always you remember. So that's why parallel operation means current division rule. Parallel operation means current division rule. Current division rule. Here current means your KVA rating. Only this is a synonymous. Nothing is more difficult in this case when you are seeing about what are the divided things. Now the same logic, because see why I want to see the transformer point of view here is that in the transformer, whenever we are seeing here, always you see here how many types of the problems, which areas you will get it. The most important area are the losses. So more problems. So V by F ratio thing and separating losses we are covering. And auto transformer is the second area. That also all the formulas we are seeing it. And parallel operation, the only 1 or 2 times it will come. Third area is a three-phase transformers. So losses, efficiency, and tests, everything will cover here. So now parallel operation is over. Now again, when you are seeing it, every year 1 or 2 questions are coming in the losses. So many times we feel that missions are most difficult. Mission subject is the most difficult, but within the mission you are having a easy concepts or easy topics. Don't miss those topics. You just solve it by formula or by concepts. So never ever miss the missions are the difficult topic. So I can't solve it. So leave it. So by after going into the exam hall, even though you know that array it is a simple thing, but you could not revise because of our fear, you will lose known things. So here is a one more question. Just I'm solving here on the losses. On the losses, that is single phase 400 volts 50H transformer has an iron loss. Iron losses are 5 kilowatt at a rated condition. Rated condition means 400 by rated condition means 400 volts 50H 50H. But when operated at 2000 volts, when operated 2000 sorry, when operated 200 volts 25H, when operated 200 volts 25H, you will get a 2 kilowatt. When operated 416 volts 52H, what are the values? Simple logic. So first of all, check V by F ratio. Check V by F ratio. If ratio is fine, go on. I already gave the formula. You find the W by F, A plus BF, find the A value and B value and solve there. It's clear. Okay, this is a easy one. I hope you are familiar with this. So 5000 by 50 is equal to A plus B 50. 2000 by 25 is equal to A plus B 25. What is A? What is B? So this one also is following the V by F. Yes, because 416 by 52, if you are seeing it, it is also following the same logic. So I got A is 50, B is 0.8. So the answer is eddy current at 52H is 60 into 52 plus 0.8 into 52 square. So what is the question he's asking? Sometimes we will totally know, but he's asking W H by WE, that is 60 into 52 by 0.8 into 52 square. Just whoever is watching, just post the answer. This is a normal one. Again, auto transformer question. Here, whatever the condition I taught you for the maximum rating, I already told you two conditions. What is this? The two conditions fulfilling, that is the 21st question. So 22 kVA transformer. See, machines, when you analyze just to view, he has given 22 kVA transformer. The transformer windings are 2200 volts, 220 volts. Distribution transformer and output. So this is the transformer given. Maximum rating they want it. Maximum rating they want it. So maximum rating, what are the conditions? The highest voltage shall be the common. So that is 22 and additive connection. That is, if you are seeing the additive connection, are you getting 2420? See, that is the question. Output voltage is 2420. But what is the input? You might be having a doubt. Sir, I am taking as a 2200. You can try for the 220. Both we will try it. What is A auto? A auto is 2420 by 220. This is 2420 by 2200. Okay. This is 1.1. this is 11. So S auto is equal to A by A minus 1 into 2 winding, that is 11 by 10, that is 1.1. Here it is getting S2 winding. Here 1.1 by 1.1 minus 1, that is 1.1 by 0.1, that is 11 into S2 winding. So 11 into 22 kV, you will get 242 kV. Here you will get 1.1 into 22. How much you will get? So just a simple logic is always the common terms must be maximum terms. So this is a maximum rating formula. Two terms, 2 points, you just, these are the two tips only, nothing. Common terms must be highest, additive connections are shall be projected. So that's the same logic in the 2016 itself. They have given the two questions, 22 kVA and 2 kVArs. Okay, now just we will move on to three phase. I already told you what are the condition in the transformer when you're coming up. Three topics, four. One is the losses side, more and basics anyway, you know it, EMF equation, that's not a big deal. And second is the auto transformer, parallel operation. Next is the three phase. So the 17th question just I am showing here. Are there any other questions you could able to see in the transformer? Yes. So before going to the three phase, other question is regulation side, that is regulation whatever it is, a regulation side is 30th question, and normal transformer is 32 question, and remaining three phase, three questions already has given. The three questions are, first is 27, I'll give the all the shortcut here. Now 17th question and 16th question. Now we will see, first of all we'll see the regulation question, that is 30th question. Just I am opening here. Yes, I hope you will answer for this. What's the question? A 5 kVA 50 volts by 100 volts single phase transformer has a secondary terminal voltage of 95 volts when loaded. The regulation of the transformer is dash. The regulation of the transformer is dash. Regulation formula, you know it. No load voltage by full load voltage by a transformer is no load voltage. Simple. The regulation we need to see V no load minus V full load by V no load. For transformer is no load. So 95 volts he has given means it is not on the 50 volts side. Never ever he mentions which is a 50 volt side, which is a 100 volt side. But as per the load voltage side, we need to understand that, oh, 100 voltage is my secondary side or load side. Okay. So 100 minus 95 by 100, that is 5 by 100 into 100%, and that is 5%. It's 5%. So regulation side, normally the problems we will see as per the load point of view. R load, L load, C load. Always you remember, regulation is nothing but output voltage with respect to rated voltage. Everyone as electrical engineer, just we will note, when you connect to the C, that is capacitive load, the voltage will be higher. So that's why regulation you will get the negative value. L load, because my rated value is this much. Normally my actual load value shall vary. So in a capacitive load, it will come here because of the load also contributes for the voltage, so that you will get a no load voltage minus full load by no load, so automatically negative. But in a L load, when you are seeing it, L load voltage is less because the L load will consume more reactive power, so voltage drops. So due to this, V no load minus V full load by V no load. So it is a maximum value you will get here. So that's why here it is a lagging side, this is a leading side. You can ask where I will get 0, sir. Yes, there are chances to get 0. That is the cases we always see it as 0 regulation condition and maximum regulation condition. So always I teach this logic is that whatever my per unit impedance is, I call it as a regulation, or always the per unit regulation we call it as a epsilon x. So what is the condition for this one? That is the epsilon x, the condition is basically the angle at maximum power factor. So what is max value? This is x is there, in the max x is there. So the tan inverse of epsilon x by epsilon r, epsilon x by epsilon r. So that is a simple logic, just the power factor at which the maximum. So here one more point, just regulation curve you understand. This is a final curve I can explain in the regulation. This is a regulation point, regulation curve. Here all the points I'll cover here. These are the shortcut and the revision point, the regulation point of view. So this is a positive regulation, negative regulation, and this is a unity power factor, and this is the lagging side, this is a leading side. So leading side, and always you feel that the regulation value is 0 to positive and 0 to negative, and power factor is UPF, and it is a 0 lagging, this is a 0 leading, that is 0.8 lagging, 0.6 lagging, 0.4 lagging, 0.2 lagging, and here it is 0.8 leading, 0.6 leading, 0.4 leading, 0.2. So the curve we need to understand here is that I already I told you where you will get the regulation negative 0. So regulation 0 you will get, that is not at this position, at this position in the leading side we will get the regulation 0, and how my curve somewhere it is maximum and later it will. So always you remember at the UPF I will be having some regulation, at the UPF I will be having some regulation, that regulation value is per unit resistance, and always at some value my regulation is maximum, that value we call it as a epsilon jet, that is percentage impedance. And what is this? This is a power factor at which max, This is a formula I am giving as a tan inverse of epsilon x by epsilon r. So you might be getting a one more doubt. What is the zero regulation power factor? So power factor for zero regulation is, normally we take it as a minimum thing. So that is cos of power factor value. It is tan inverse of epsilon r by epsilon x. Epsilon r by epsilon x. So that is the thing. These are the simple logics. At unity power factor, you will get some regulation value that is equivalent to, what is this? This is a percentage r, that is r per unit. Whatever the per unit value they are giving, that is the value. And this is the impedance, that is percentage z is z per unit, that is the value. This is the overall shortcut for the regulation. Whatever the technical point it is coming, you can keep it. What is this? This is percentage reactance. The terminology changes, because if you are seeing the BIMRA, this type of the terminologies, you will get it. Epsilon x by epsilon r. Nothing means that is a per unit value. If it is in a percentage, it is in a per unit value. Nothing is this. So epsilon x by epsilon r. Yes, Ashwin. Very good. 5%. Ashwin 1.44. Sorry for late reply from my side. Yes, Ashwin, good. Mm. Okay. Shall we move to three-phase side? So three-phase side, just I want to give an introduction of 27th question. If the primary line voltage rating is 3.3 kV star side of a 25 kVA, so star delta transformer, that is per phase turns ratio is 5:1. Then the line current rating of the secondary side. So this is a little understanding what is the logic behind this. So the transformer is star to delta, and he has given primary line voltage of star side, and the turns ratio he has given, the per phase turns ratio is 5:1 transformer. The line current rating of the secondary side, so 25 kVA, and we can calculate, there are different way of calculation for this. Anyone can give the guess, or if you know the answer, you just type here. You can use the chat room. Just I'll give some time. Hmm. Hmm. You know it takes time, so I'll give 5 minutes time. Just try. This is also simple shortcut table I'll give. Mm. Mm. Anyone? Okay. So for this simple formula, normally I used to follow. What is this? Is whatever the connection it is. Okay. Suppose if I am taking the delta to star, here it is that is a connection. No, star to delta. Okay. That one only we will take star to delta. Voltage side is a one formula and current side. Always the turns ratio, whatever the turns ratio is giving, that is a phase relation only, not with line voltage. So I know the line thing, I know the phase thing, and I want to know the star side and I want to know the delta side. The current when I'm talking about star, delta, line side, phase side. Hmm. So what is the relation he has given? First of all, the relation we need to understand is the 25 kVA. The relation is 25 kVA, 3.3 kV. The relation is 5:1. So what he has given? He has given the primary side line voltage is 3.3 kV. So he has given line side is 3.3 kV. So you know it, star side 3.3 kV means phase relation is 3.3 kV by root 3. Now the relation is 5:1 relation. So that is already here told star to delta, that is phase turns ratio. Now when you convert this one, what you will get? 3.3 kV by root 3 into 5. And delta side we need to understand is line voltage and phase voltage, 3.3 by root 3 into 5, because in a delta both are same. So the point is that from the phase ratio, if I know the line side, I will get the delta side. This is a table, always it is best to use. There is no confusion, no need to buy heart anything. Simple logic, no need to buy heart. So 3.3 kV is the input side and the relation we got it. Suppose what is the basically he's asking? Current is asking. So now voltage I got it. How to get the current? So one more logic what I used is that normally no need to calculate this one, but this one also or this one. So first of all, the KVA rating is 25 KVA rating is equal to what is the voltage rating? Now I need to know it to root 3 VL IL. So VL already has given, IL I need to find. So start side 3.3 kV and root 3, this is a 25 kVA. So IL is equal to 25 K root 3 3.3. So line side, star side, I am getting the current. How much? That is 7.7.7 by root 3. So in a star side, line current and phase currents both are same. That is relation is 5:1. Always remember, from star to connection 5:1, the voltage is reduced, but current is, so 7.57 by root 3 into 5. Here it is divided by 5. There it is a into 5. And in a delta, phase to line current relation is root 3 times. So 7.57 into 5 into root 3 by root 3. What is the current value? That is 37. Just this one is sufficient for us. This one is sufficient for us. So whatever the value they are asking, it doesn't matter to me. Either here they are giving the phase relation, or sometimes what they will do is that the values related to this is a line voltage relation. Never ever use this one for the transformation. Always the transformation logic is this is a flow. That is the only flow. Transformer always transformation ratio is giving means that is the phase one only. I hope you understood this logic. So the answer is around 37.8, whatever it is, the answer you can write, because it is a filling the blank, even if you are not having the. I hope you understood the three phase. So these are the basic introduction and easiest problems sometimes we will receive with a little bit effort. Only here nothing we need to know. Only star and delta voltage and current transformations we need to know. Nothing is more. Any doubts? Any doubts? Hmm. This is the one more important. Basically, this is the winding. These are the winding diagrams. So basically, this is not a very difficult thing, but by seeing the understanding, we can easily know it, because line side there is no difference. If you're coming to here, this is a star, this is a delta. So we need to know it. What is the phasor difference in between the voltage V1 and V2 is simply we can write star to delta is 30 degrees. Suppose if any other answer, because it is this way when you are seeing it, one more way to see this type of the problems are exactly the clock diagrams. So that anyway we can know it too. Because here also a only it is there and here also a, that is why simply we can close the matter with 30 degrees. These are basically, this is a, when we are talking, this is a power system related question, but anyway it is a transformers have come under CT, but this is a power system in a power, but both sides people always teach this one. See, what is a three-phase transformer rated 33 by 11 kV is connected in delta star as shown in figure. The current transformer CT is on low and high voltage sides having a ratio of 500 by 5. Find the currents I1 and I2 if fault currents is 300 amps. So if fault current is 300 amps, what are the currents? So it is a star delta relation. Always remember, if it is a star, the connection is delta here. If it is delta here, the connection is star. That is the only logic you need to remember in the power systems when we are using the differential protection. In the differential protection concept, only one logic is, if it is a star, here is a delta. If it is a delta here, here is a star. Because CT connection is always reverse to the main transformer. That's the logic they use for the here you see. That is a one important logic, and especially when you're coming the entire current, what is the I2 and I1? So basically entire current is flowing in is fault. So the primary kVA and the secondary kVA side, when you're seeing it, that is 500 by 500 ratio, that you can see here 16th. Primary kVA, secondary kVA. So the what is primary kVA? Root 3 into 33 kV into IL, load current. I don't know how much is the load current, but root 3 into 11 kV into, we need to understand how much current is flowing, that is 300. When now we can use the CT ratio. What is the CT ratio? That is 500. So this much is the current is flowing. Now when you are seeing this one, we can get it, the IL is 1 amp. I want the line, so IL line current is root 3 into I phase. When you are seeing it, I phase is 1 by root 3. Answer is A. So now I'm closing the transformer here. Any doubts if you are having any doubt you are having on this topic? Now I will start the induction machine and synchronous with concepts after some break. But just I am waiting for your questions. Please post on the chat room. I'll wait for those. So if you are preparing or you are revising the machines, if any doubts are coming on this topic, you just let us know. Mm. So just one session is, so now it is 6:10. We'll take some break. So we'll come back by 6:25. Please tune and please follow the link, and you please revise your notes. As if you are having any doubt, please post in the chat room. Once we'll back, we can see that one. Okay, good evening, one and all. So, just I'm starting the basics of induction mission. So, as a revision, not only questions, so questions also will parallelly come with that. See, as we are seeing the induction mission topic, okay, as we are seeing, so basically we need to understand the rotating magnetic field concept. We need to understand rotating magnetic field. That is, what is the phase sequence point of view, ABC and ACB sequence. Next, we can see that as how it is for the three phase and how it is for the M phase and how it is for the two phase and single phase. And after that, anyway, constructions we know it too. And operation point of view also we know. One more important is torque equation. The second topic we can see it is as a torque equation. So the relations we can see, that is maximum torque, the full load torque, the starting torque. So power flows also we know, that is that all also equation we see to power flow. And next when you're coming up, the speed control or speed control. Next we can understand the starting methods, because three phase induction motor is a self starting motor. Three phase induction motor is a self starting motor. Starting methods, but starting methods is to reduce the starting current. So these are the normal calculation, the power flow and the losses itself we will see there. So main topics when you're coming up. So first point to understand is RMF, that is rotating magnetic field. Rotating magnetic field. So what are the rotating magnetic field concepts to understand are my stator. One important point we need to understand here regarding the stator side is, for a balanced winding, if you give balanced supply, the balanced winding, if you give balanced supply, so obviously what you will get, the rotating magnetic field with a constant speed, ns is constant. So what are the conditions to be fulfilled? So balanced winding means 60 degrees phase space spread winding, that is a concept. And balanced supply is 120 degrees phase shift supply. This is also same one. So my three phases, the opposite phases, that is R, Y, B, R dash, Y dash, B dash. This is 120, but phase to phase is 60 degrees. So my each phase, one side of the phase is spread for 60 degrees. That is why this winding is called phase spread winding. So in this, when you are seeing, what is the concept we need to understand is, if you're conducting balanced winding and to balanced supply is given to balanced winding, automatically there is a rotating magnetic field is produced in the stator. Due to the mutual inductance, my rotor is short circuited anyway, so rotor also produces the flux, but rotor is, due to the Lenz's law, oppose the cause of reason. So cause of production opposition, by seeing this, the cause of production is relative motion. The relative motion to be reduced so that the rotor is also rotates in the same direction. This is a ns speed, this is a rot. So my relative speed, technically this is a normally aptitude wise we call it as a relative speed, but technically this one we call it as a slip speed, nothing difference. So that is ns minus nr. If I want a slip with respect to speed, that is ns minus nr by ns. So this is the formula come up. So always the logics come here is that always we need to see there is a slip. So the stator is fixed. The stator speed is the stator rotating magnetic field speed. Just it is like a trains. Okay? Stator flux is rotating, that is RMF. Rotor is rotating. So on the rotor, this is rotor is rotating. Rotor flux will be generated with the relative speed. That is the relative speed. We call it as a SNS. You see now, what is the slip speed? Slip speed formula is slip speed formula is So the slip speed is ns minus nr. This we can write it as a SNS. So always the concept we need to understand is the rotor is rotating with the nr speed. On the rotor, the flux is rotating with SNS. So what is the point we need to understand is, if by stator rotating magnetic field is rotating with ns, the rotor rotating magnetic field, because here rotor is rotating over that SNS is there. So nr plus SNS is ns. So this is a thing we need to understand. So that one important point we need to understand is the relative speed between rotating magnetic field of stator and rotor are zero. So this is an important concept we need to understand. So now the questions. The stator rotating magnetic field with respect to stator is ns. Stator rotating rotor rotating magnetic field with respect to stator rotor rotating field, because both are rotating at same speed ns. The relative speed between stator flux and rotor flux 0. The relation between r to phi r is sns. R to phi s same sns. S to r nr. Over. So this is the way the relative speed concepts will come into. Now, when we are seeing here, what are the concept point of view we see here is that, so when you are seeing it, the three phase relations and whatever the things, M phase, everything will come there. Now, the transformer equivalent circuit. So now, as per our concept point of view, the rotating magnetic field and basic things. So ABC phase sequence means the stator is rotating like this, then rotating magnetic phase sequence is reverse, the rotating magnetic field will rotate in the negative direction. So if you are changing the phase sequence, automatically rotating magnetic field will reverse its direction. That's it. So for the three phase, for the M phase, same logic. Whatever I told, that is balanced winding and balanced supply. So one thing we need to understand is basically the balanced winding 360 degrees by M, 360 degrees by M. That is, this is for winding, this is for supply. But the condition is applied only more than two phases. M is more than two phases. So M is more than two phases. That is 360 by, if it is 3, then 120 degrees. Supply is also 360 by 3, 120 degrees. If you are taking more than 2, automatically it will apply. But for two phase and single phase, the difference. For two phase, the phase angle difference and the winding must be 90 degrees. So for the same formula, if you use the 360 by 2 means 180 degrees, it won't work. So that's why for the two phase it is 90 degrees. For single phase, you know it, that is a concept we talk about. Off is rotating like this and off is rotating like this. So different concepts will come because a single phase you don't have a rotating magnetic field. So that's why the two phase. So for single phase also will convert into two phase, then you will get into. So these are the concept just for the rotating magnetic field point of view when you're coming out. Now, as per power point of view, now imagine how my induction motor is rotating. So the induction motor power formula, when we are understanding here, my supply is connected here. Okay, supply is connected here. The rotor, sorry, first it is going to stator. Stator it takes some losses, then it releases to rotor. So rotor keeps some losses, then it goes to the shaft. So supply and losses, then it is going to the stator, then it takes some losses and it gives to the shaft. So that is a power flow when we are talking about how my tree it will talk about. That is my stator input first of all, that is losses, stator losses, because stator is operate at a rated frequency. So V rated, F rated. So you will get all the core losses. Then stator output. So stator output means rotor input. Normally air gap losses we don't take. Now again rotor losses and rotor output. Rotor losses is the copper, not the, so rotor output. So rotor output when you're talking about, once the rotor is coming out, this is a in output, it is generated inside, but there are friction and windage losses. Friction and windage losses, then shaft power. So this is the output power. So always we need to know the relation between the rotor input, rotor losses, rotor output. The relation we need to understand is rotor input, rotor losses, rotor output. So the relation always we see here, it is that one more, just to make more visible, I am changing the color. This I call it as a air gap power. This I call it as a PR copper. This I call it as a P mechanical. This I call it as a P shaft. So the relation always we take it as a PAG, whatever the power is there. PR copper is slip times it will consume. So suppose here it is 100 is there, here it is 5 means What I can take is, this is 5% means 5% into 100. So it takes 5 watts. Then whatever is remaining, that is 100 minus 5. Same way, 1 minus S into PAG is P mechanical. So always this is a relation you need to remember. Rotor input to rotor losses is depending upon the slip. So the relation when we are talking about rotor input, rotor losses and rotor output, that is mechanical. This is PR copper, that is input power, that is PH. If it is 1, this is S, this is 1 minus S. So ratio is same way. If it is getting 100, my slip is 5%, so I'll get 5 watt. This is a 95 watt. This is the most important logic we need to understand for the power flows. This is the power flow equation, and these are the equation we can understand. Now we'll come to the torque. So torque slip characteristics we need to understand. Here is the torque slip characteristics. This is torque, this is slip. So always we need to see, here it is a slip is 1 means, so 0, slip is 0 means speed is ns, slip is 1 means speed is 0. So the relation is always, slip to speed relation is 0 to 1 and 0 to ns. So my relation I'll get is, when the initial, if I'm having a good starting period, it is an inverse relation. So that if you are understanding, if the speed of the ns is corresponding, always this is a relation we need to see. This is the starting torque, this is the torque point of view when I'm talking. This is starting torque, this is a maximum torque, but this is not the maximum slip, this is a slip at maximum torque, slip at maximum torque, not the maximum slip. Maximum slip is 1. Okay, so the S is small, directly proportional relation. If S is high, inversely proportional relation. The same speed when you're talking about, it is in a higher speeds, T direct proportional to S. In a lower speeds, T is inversely proportional to S. So this is a torque slip relation. So what are the relations I'll get? Maximum speed torque, maximum starting torque, maximum torque, and full load torque. They are the 3 things. So when you are seeing what is the formula for the torque when you're coming up, the torque formula is very simply, we can write it as that 180 by omega s into e2 square r2 by r2 square plus sx2. So when you're coming up, the relation is the maximum torque. Maximum torque, when you're seeing whatever the relation we are seeing here, the maximum torque condition, whichever we see, that is R2 is equal to Sx2. The condition for a maximum torque is this one. At this condition, so what is the S max, that is S at maximum torque is R2 by X2. So at this slip, whatever the speed we are getting, that is called, we call this as the stalling speed. Speed at maximum torque, that is stalling speed. So ns into 1 minus sm. Sm is, seems to be, it is a maximum, but it is not a maximum, but slip at maximum torque. Okay, so that's why we call it as a SMT. For my notation, I used to represent this one. So maximum torque, if you substitute this one, the maximum torque equation, what you will get is 180 by 2 omega s is common, that is 2 pi ns, sorry, because omega s, if I speak 3 by ne2, right? And the equation you will get is e2 square by 2x2, no other relation. Here r2 is there, that gone, only x2 you will get. Here slip is also gone. So one thing we can understand is that T is always directly proportional to voltage, and maximum torque is inversely proportional to x2, and maximum torque is independent of rotor resistance. Independent of rotor resistance. So in this one important logic, just I want to clarify here, V by F ratio is constant, V by F is not constant. So in this, always you need to remember this is a Tm. What is the relation? If V by F is constant, leave it. What are the condition? 180 by 2 pi ns means here one F is there, and in the E there is a one F. Okay, you write it as a E only, not a F, and in the this one also one F is there. Okay, so E by F is constant. Then what will happen? My Tm is inversely proportional to 1 by F. Just you understand that what are the relations are dependent upon F and what are the relations independent of F. So here when you're seeing the relation is Tm is inversely proportional to, if V by F is constant, then this is a relation we'll get it. Suppose second case, if V by F is not constant, in this case Tm is, here is one F is there and E by F. So Tm is 1 by F square relation. So the 2 points just I want to clear here is, V by F is constant case, V by F is not constant case. Then Tm is directional to 1 by F. This is 1 by F square. Sm, when you're talking about Sm is anyway it is related to 1 by F only. There is no relation with the. So that's a way we look at, that is SMT. Sm means SMT. So 5 points always, each torque we need to remember. One is my torque is direct proportional to supply square, means voltage square, and the second, what is the relation with resistance, that is second one, what is the relation with the inductance. So here when you're seeing the maximum torque condition, so the maximum torque never depend on the resistance, and the reactance already seen, that is an inverse relation. So and next relations we have seen, V by F is constant, then how my T max is dependent on F, and T max, what is the relation? So 180 by F. So if V by F is constant case, is it depending upon the F or not? 1 minute, just here itself we will change it. 2 pi F E by F. E by F is there. Yes, this is a relation we could see here. Now same relation we'll see the T start. What is T start's formula? T start is 3 by 2 pi omega s E square by x2 square, that is into R2. Basically R2 is there. So what is the difference with the maximum torque to starting torque is, starting torque is depending upon the resistance and inverse proportional with the reactance. So the first is T start is directly proportional to V square, and second is T start is directly proportional to resistance. Third one is T start is inversely proportional to 1 by x square, and fifth one when you're coming up, so V square f square and 1 by f is left. So if v by f is constant, that time t start is 1 by f relation. If it is, this is v by f is constant case. V by f is not constant case when you're saying t start is 1 by f cube, it will come because v is constant, it is not depend on f square into f. When you're talking about this is a f cube, so this is 1 by f, this is 1 by f cube. So these are the relations we need to understand when v by f is constant case and v by f is not constant case. So these are the relations we see here. So that's why the total equation it is depending upon, and it goes on. And one more relations we will see, it is that always the relation with the full load torque to maximum torque and starting torque to maximum torque. Starting torque to maximum torque is, we'll say it is as a plus 1. A means it is nothing but R2 by L. Sometimes we can write it as a SMT also. So if a additional resistance is, that time we will mention as A, otherwise it is a maximum C. T after Ts is 2 SMT S full load by Sm square plus S full load square. These are the two formulas we normally remember with respect to. So no other concepts are left with this. If any doubts are you are getting it, please note down and we can solve. Now little bit before the speed control, will go on to the some problems so that concepts and questions can be matched. So what are the induction questions we can see here are just we'll see the formulas problems. See the 12th one. A three-phase 50H 6-pole induction motor has a rotor resistance of 0.1 ohm and reactance of 0.92 ohms. Neglect the voltage drop in stator and assume that the rotor resistance is constant. Given that the full load slip is 3%, the ratio of maximum torque to full load torque. So the same formula. So maximum torque to full load torque, what is the formula it is left? You just see here. I hope I am expecting answers from you now from the chart. Please use the chart room once you solve the problem. The details has been given. What's the answer? Can I get it in the chat? So now the formula, you know it. What are the data he has given? So frequency is 50, R2 0.1 ohm, X2 0.029 ohm, SMT is 3%. So what is T max? T maximum by T full load. That is a reverse relation. That is SMT square by S full load square to SMT SFL. So the data is SMT is already we know it, R2 by X2 0.03. So If you substitute S full load, already we know it, 0.108, sorry, 0.108. So 0.108. So 0.108 whole square plus 0.03 whole square by 2 into 0.108 into 0. For full load slip, he has given the slip is 3% now. So one slip he has given, another slip he will ask. Sufficient. Full load slip, sorry. Full load slip is, this is not a, full load slip is 3%, SMT is 0.108, gone. Then you will get the answer 1.9. So in an induction machine, not many problems are, means not many equations shall we remember, only few concepts. If you remember automatically the equations, you can continue to solve. Continue to solve those. And one more question. Hmm. 24th. 24. A 4-pole induction machine is working as an induction generator. The generator supply frequency is 60 Hz. The rotor current frequency is 5 Hz. The mechanical speed of the rotor in RPM is. A 4-pole induction machine is working as an induction generator. The generator supply frequency is 60 Hz. Now it is a generator. So these are the concept we need to understand as the modes. So modes of operation. There are 3 modes of operation. Motor, generator, braking. Motor is slip is 0 to 1. Generator slip is negative. Brake is 1 to 2. Here why it is negative? Because if my stator is rotating like this, relative speed is this is a braking is this is a model, and here why it is negative is here, but the power comes in the negative direction. So that is why if you are seeing it, the slip point of view when now coming, here 1 minute, the concept we need to understand here is why it is negative, or my rotor speed is greater than synchronous speed. Here my rotor speed is less than s, that's why s is positive value but less than 1 value, 0 to 1. But here s is negative. How it is? S is equal to ns minus nr by ns. If itself it is a negative, then automatically s is negative. If s is negative, then that mode is called generator. And braking means this is a stator, this is a rotor. So what is happening? My s is equal to relative speed. Relative speed is opposite sides means plus ns plus nr by ns. So this is the point we need to understand here. Now generator point he has come up. So what is the question he is speaking? 24th question now. What is 24th? So P is 4, working as induction generator. The generator supply frequency of 60 Hz. The rotor current frequency is 5 Hz. So what is the mechanical speed of the rotor? He is asking NR. Okay. So he knows it, F R. So it is a 60 Hz and 5 Hz. Now I'm just waiting for the reply, please. Now I explain the concept. Now you start doing it. Any output? So here, when you're writing the formula for here is nr is equal to ns into 1 minus s. Here we can write the formula as nr is equal to ns into 1 plus s. So nr, ns is, this is the formula we need to write, that is 1800 into 1 plus s, that is s is rotor frequency by main frequency, that is 5 by 60, that is 1 by 12. So 1800 1 plus 1 by 12, we will get 1950 rpm. As I told, stator rotating magnetic field is 1800 only, but rotor is rotating with 1950. Hmm. Hmm. What are the other question? Hmm. Very good question. 26. 26. I'm expecting answers from your charts. Please go on. Okay. What is he asking? 26 question. 26 question. 3 phase, 4 pole, 400 volts, 50 H. Squirrel cage slip is at 0.02. Rotor flux speed is asking. not the rotor speed. Many people will get a confusion. Rotor flux rotate with a speed of ns. That too is asking in a mechanical. Basically, ns is 120 f by p. That is 120 into p. 4 by 50 by 4. 1500. And he's asking in the mechanical radian. So 1500 2 pi ns by 60. So here two logics. He's asking the rotor and mechanical radiance. If blindly if you go with the 1500, then gone. So answer is C. Not the rotor speed, rotor flux. Now we'll go to the synchronous mission. Synchronous mission will go. Just basic concepts to understand here. Most important, they always give the synchronous impedance. That concept we always get into and we understand that one. Okay, that anyway, that crux I will explain you. What are the other points we need to understand is winding things we need to understand. So 3 points, not much. First is the coil span. Second one is pole pitch, or you can call it as a pole span. Third one is the slot pitch. This is with beta, this is with gamma. If you are having any other notations, it's okay. Pole pitch means the distance between the two poles or distance between the two adjacent poles. Okay, that is a pole pitch. And what is a coil span? Here, when you're talking about the winding point of view, always we need to understand full pitch and off pitch. So the coil span beta, normally we take it as a 180 degrees electrical, or it must be equal to pole pitch, and it must be equal to slots per pole. These three equations are most important. This is full pitch coil. Beta is 180 degrees electrical, pole pitch, and slots per pole. It is a full pitch. If it is a short pitch, the equation is less than 180 degrees, pole pitch, slots per pole. Slots per pole. So in this, when you're talking about slot angle, just you take an example. No need to by heart the equations. My pole north to south, always it is a 180 degrees electrical. Okay. So if it is a two pole, normally two things. Suppose here it is having some 10 slots or whatever it is. So total angle, how much we can take? P into 180 degrees is for S slots. So per one slot, P by S into 180. So the slot angle gamma is equal to 180 degrees by slots per pole. That's why this is the most important equation, slots per pole. If it is equal to 180 degree, that is a full pitch. If it is 180 by slots per pole is a slot angle. This is the most important. That too all are in electrical. All are in electrical. So the point we need to see here is there are many such equation and two factors, that is a pitch factor and distribution factor. The pitch factor Kp, normally we talk it as a cos alpha by 2. Okay, distribution factor, when you're talking about, always the distribution factor is the formula itself will come up. Now we'll see the pitch factor. So cos cos alpha by 2 is a pitch factor. If it is for the nth harmonic, that is Kpn is equal to cos n alpha by 2. So n alpha by 2, I want a Kpn is equal to 0, that is n alpha by 2 is 0, and that is cos 90. So what is a alpha? That is short pitch angle. Alpha is a short pitch angle. Short pitch angle. Alpha is a short pitch angle. That is pi by n. And beta is 180. So now diagrammatically you understand here. If my winding is full pitch winding, this we can take it as a 180 degrees. This is alpha, short pitch. So coil span beta is equal to 180 minus alpha. So that is the formula we take into. This is a normally full pitch. This much is a short pitch. This much is a short pitch. So short pitch alpha already we have found it. That is 180 by n. So coil span in the short pitch angle is 180 minus alpha. That's why you will get 180 1 by 1 minus n. So whatever you are taking, if it is you want for the fifth harmonic to be removed, alpha is equal to 180 by 5, 36 degrees. Seventh harmonic to be removed, 180 by 7, that is 25.7 degrees. So this is a 36 degree, 25.7. So this is a way normally we calculate short pitch, full pitch, and the thing. And one more thing, the distribution. Here one more terminology we need to learn is that phase belt, phase spread. So all are same. Phase belt, if it is a number, in how many number of slots, we can call it as a m. If it is a phase spread angle, we normally talk it angle line. So that is a m into gamma, because how many slots are there, m will speak. How many our total angle, that is number of slots into slot angle, that is m gamma. That's a simple logic. So that's why m is equal to slots per pole per phase. Slots per pole per phase, and phase spread is m into gamma. So this is the formula when you're speaking about phase spread angles. This is a normal formula. So that the distribution factor is sine m gamma by 2 by m into sine gamma by 2. What is m gamma? This is a 1. So m you will find by this. Gamma already know it, 180 degrees by s by p. M you know, and gamma. So this is a way normally we solve the problems. Now here recently people are means that different of angles are coming up. Suppose I have a three-phase machine. I want to change that same slot, same winding. I want to use it, but I want to convert into two-phase. So here normally they will ask the relation of voltage and relation of power change. So relation between induced EMF and power, that is especially the kVA rating. So the relation always we see it is that P is always we see it E directly proportional to transfer phase E, voltage directly proportional to transfer phase and KD E, and P is directly proportional to KD. So for this type of the relation, the KD plays very important role. So the relation of KD, it gives the relation between. So here one more important we need to understand is that for single phase, for two phase, for three phase, how the KD is. So if it is a whatever the things, so that is the how the phase spread is divided between the single phase and phase. When you are seeing the phase spread for the single phase is speaking about 180 degrees, for two phase it is 90 degrees, for three phase it is 60 degrees. So three phase normally short means you have a different types of windings, that is broad and short type of, that is 60 degrees and 120 degrees type. So these are the different terminologies. So if E is there, KD relation and K. So I want KD single phase relation, KD two phase relation, KD three phase relation. Okay. So how the KD is related? KD formula, what is the formula? Sine. This is M gamma. This is phase spread. So M gamma by 2 by M into sine gamma by 2. So M gamma for single phase is 180. So sine 90 by M is 180 by gamma into sine gamma by 2. For two phases, sine 90 by 2, 90 by gamma, sine gamma by 2. For three phase, sine 30 by 60 by gamma, sine gamma by 2. So by based on these relations, first if I want to bring the relation between KD 60 to KD 90. So KD 60, what is the formula? Sine 60 means this is on three phase, two phase. So that is sine 30 by 60 by gamma, sine gamma by 2. Just I am giving the relation so that you no need to by heart the things. Just I am explaining one concept. 90 by gamma, sine gamma by 2. So that is sine 30 by sine 90 into 90 by 60. This is anyway 1. This is of 2. So the formula will get sine 30. This is a 90 by 2 now. Sorry, this is 45. So 1 by root 2. So this is 1 by 2. This is 1 by root 2 and this one. So total relation is 1.06. So if I'm talking about the power transfer between these two, that same, that it means same means KD and P is same. So P three phase to P two phase. The relation is 1.06. No need to do any other calculation. Only KD is sufficient. But for the E three phase by E two phase relation, phase only, phase only, phase only. So KD 60 by KD 90 into turns. So turns three phase by turn two phase. So this is anyway 1.06 and this is turns T by mean T by 3. Turn 2 phase mean total turns by 2 phase. That is 1.06 into 2 by 3. So you will get the relation is root 2. So that is the way the problem used to solve here. Just let me check if that problem, I think I would have given this. I normally I give that one. So just let me check with that. Ninth question. Ninth question. I'm showing. Hmm. 24 alternator is having 180 degrees identical state slots and 6 conductor in each slot. All the coils of the phases are series. If coils are reconnected to relay single phase winding, the generated voltage is V1. If the coils are reconnected to relays the 3-phase star connected winding, the generated phase voltage is V2. Means the relation we need to find between 3-phase to single phase, the two voltages. So is asking the single phase by 3-phase is voltage relation. So for that, normally we can go on see that one, but I prepared my own table for my own preparation. So just the answer 3-phase to single phase voltages when you're talking about the answer might be 2, because here it is a 3-phase to 2 single phase. I wrote it as a 1.5, but here it is 1. So answer is 2. So how it is, you can derive it. Just I'm showing here. E single phase by E 3-phase. So that is KD single phase is 180 by KD 60 into T by 1, sorry, T by 1 to T by 3. So KD 180, KD 60. So that's the formula we need to see. KD 180, KD 60. That is sine 90 by 180 by gamma, sine gamma by 2, sine 30 by 60 by gamma, sine gamma by 2. Then 1 by 1 by 2, 60 by 180. So 2, 3. So 2 by 3 is a KD, 2 by 3, and this is 3. 2 is the answer. No need to by heart anything. I have prepared the shortcut table, but I don't want to give because this is a simple way. No need to by heart any of the equation. No need to by heart any of the formulas. One thing, only KD formula anyway it is remembered to all of us. So sin m gamma by 2 by m into sin gamma by 2. Just how to use that formula is the only logic here. So this is the formulas and problems normally we used to get. The new way of understanding the problem. Now we are seeing the EMF equation. So however we have seen the equation in their induction machine, the same way of induction here also we can understand. How the volt? What is the voltage equation? Okay. So as a synchronous generator, when you are seeing here the concept, just imagine field is coming out through by the rotor, stator winding is there, EMF is generated, that EMF, whatever the highest EMF is generated in the armature, that is called no load EMF also, or open circuit EMF, EF, that EF is generated, and there are the losses, that is resistance and inductance. Then at the end it will come to the terminal of the generator, that is called terminal voltage. So this is the field flux. So as we are seeing that, okay, the first EMF is generated is EF. Resistance and inductance are there in the winding, RS, XS, then this is called VT, this is called IA, this is the EF. So this is the thing we understand is that EF is equal to VT plus IA ZS. Simple logic. And here the formulas always we remember is that armature reaction. Armature reaction. So if this is the power factor, what is the demagnetizing, over magnetizing, all these logics will come up into. So that is also not to more worried. So if it is a generator is a one logic, and if it is a motor is a one more logic, that is the thing we need to understand. So armature reaction is an important thing, and voltage. So I hope you know the armature reaction logics. If you are still by hurting the array wow, and that is a leading power factor, this is a demagnetizing effect, over magnetizing effect, and cross magnetizing. If you are by hurting it, then no use. Always remember, okay, flux is the first thing it will come, after that EF will come, okay, due to the E the current will come into. So it is having a flux also, so current is coming and flux. So here if it is my unity power factor, always generator is whichever the direction of the E, current direction is also same. That is a generator logic. Sorry. So here what is the relation? Phi f is coming like this and phi a is coming like this, cross. So cross magnetization. Generator UPF is cross magnetization. What about lagging? Phi f is fixed. After that EF comes, lagging load. So current is like this, flux is like this. So both are, flux is like this, armature is like this. So demagnetization. Leading, flux, EF, leading. So phi a is also like this. So IF, IA, over magnetization. So if it is a 0.8 lagging, so are the cross are the demagnetization, and if it is a 0.8 lagging, are the cross are the over magnetization. This is simple logic. No by heart. I also don't know. Just I'm explaining to concept, that is a conclusion. So motor, what is the difference with the motor and generator? The generator and motor difference is, if it is a phi A, this is a E. In the generator, the current voltage and current directions are same, but in the motor, voltage and current directions are opposite. If generator current is like this, the motor current is like this. That's why some relation. So if it is a UPF, cross magnetization only, but downward IA. If it is a leading power factor, it is a cross magnetization. Sorry, it is a demagnetization. If it is a lagging, it is a over magnetization. So if you know the generator, automatically motors are the reverse formula. So now we understood what are the equations and what are the EMFs are coming up, and here also regulation, what are the small equations will come up. The condition for the maximum voltage regulation is that is fixed, that is theta is equal to 5, that is a power factor angle. So these are all logics we see. Now most important is the ZPF and EMF methods. So now, and excitation things. So just let me see what are the problems are there. Accordingly we will see that one. 1 minute. Where is my pen? One is over, two is over. Eighth we need to solve. Just I'm noting down the point numbers. 8. This is solved. This 10. Solve. On. We'll see 13. 25. First we'll solve the 34th question. 20 volts 3-phase star connected synchronous motor has a synchronous impedance of 0.25 plus J 2.5. The motor draws a rated current of 10 amps at 0.8 power factor leading. The RMS value of line to line internal voltage in volts. Internal voltage means EF. So EMF equation, if the generator means current goes out, motor means current comes in. He has given the line terminal voltage he has given. So he is asking EF. So what is the formula? In this, if you are talking in a motor, it is called EG. That is a back EMF concept. So EG or EB is equal to VT minus IZ. So that's a simple formula. So I hope you do it. So Hmm. Just whatever the question you're getting, first write the equation. What is the data he has given? 220 volts. Line. We need phase. The impedance is 0.25 plus J 2.5. Star connected. It is 10 amps. 0.8 lag EF. So EV is VT minus IA ZS. If it is generator, EF is equal to VT plus IA ZS. That's the difference. This is for generator, this is for the motor. So VT minus IA into ZS. So VT has given 220 by root 3 minus IA. So 10 at an angle minus 36.86. It's a lagging, right? Leading. So plus. It's a leading. IA ZS is 0.25 plus J 2.5. So normally EB will get, well, that is 1.11 into minus 8. So this is a phase. I want the line. Line is equal to 245.36. Okay, that's over. That's the way we need to see the question and understand the thing with our equation. So this is also over. Now what is another, that is 25th question. A three-phase 50 star connected synchronous cylindrical rotor synchronous machine is running as a motor. The machine operated from a 6.6 kV grid and draws a current of unity power factor. The, the synchronous reactance of the motor load angle is 30 degrees. The power delivered to the motor. Give the answer up to 1 decimal. So just give it. Just write. This is also same like this one, but load angle he has given. So only 1 point it will change. That is E at an angle delta you need to take. Just I'm giving some time, so just do it. Hmm. So 25. The question is three phase 50H, star connected, single machine running as a motor. Now he has told that it is operation is a motor. Machine is operated at 6.6 kV grid, that is terminal voltage. That is whatever I told. This is 6.6 kV. Draws a current at unity power factor. The synchronous reactance is 30 ohms. So that is 30 ohms. And load angle is EV at an angle delta. Basically, this is a minus. One thing you understand, in a generator, if it is V, EF comes like this. In a motor, this is V, EV comes down. That's why this is minus delta, this is plus delta. If you are writing the equation, EF at an angle delta is equal to VT at an angle 0 plus IA at an angle plus or minus 5, ZS at an angle theta. This is the equation we write. But when you are seeing here VEB, so EB at an angle minus delta is equal to V at an angle 0 minus IA at an angle plus or minus 5, ZS at an angle theta. This is the formula we understand. So EFN. So this is like a two transmission, means two voltage sources, generator and load point, middle equation is here. So just what is the power transmission equation? Power transmission is equal to EV by X sine delta. First we need to understand how much is the delta, already he has given, and we need to know E. So if it is a three phase power, if you want, that is 3, you need to know it, and this is the EB, and because delta he has given 30 and Vt he has given, X he has given, but only unknown is EB. So in this equation, we unknown thing is EB. So what is the relation between the voltage and EB? That is a point we need to understand. So here itself we can understand that the relation between EB and this one is EB cos delta is equal to V. So EB is equal to V by cos delta. That is V, whatever the voltage is there, and divided by cos delta, then that is you will get a EB phase. So this is a phase thing. If you multiply with the 3, then you will get 3 phase. So that's why 3 into whatever the voltage you are getting, maybe you will get 4.4 kV. So 4.4 kV into 3.81 kV divided by 30 into sin 30. Then you will get 838.31 kilowatt. So I hope you understood the point. Now we called of 25. So 8, 10, 13 only questions are left. Just open next sheet. A synchronous generator is connected. Now it is a generator. Generator is connected to an infinite bus with excitation voltage of 1.3. So EF is given and generator is having a reactance. So XC has given. Just it is a network EF, ZS and VT delivering real power. So P he has given. Assuming infinite bus voltage is 1. So VT has given, XC has given, EF has given. And P also he knows it. Now he is asking the reactive power supplied by the generator. Now you know the P, you need to find out it. Do it. We know the formulas P. So P he already has given, V already has given, X he has given. What is the unknown thing we can find? Delta. So first you find the delta from there. So Q formula also we know to EV by X cos delta minus V square by X. Katham. Done. Always the synchronous mission we need to look at as a power system. Two side sources are there and middle transmission line is there. It is having inductance and whatever the power equation is there, whatever the delta is there. Simple logic. The synchronous missions we can convert into transmission line. Mm, mm. I'm expecting answers. Mm, mm. So the way of doing is P is equal to EV by X sin delta. So delta you might be getting 30.5. Then Q is EV by X cos delta minus V square by X. That is 1.3 into 1 by 1.1 into 0.86 and minus 1 by 1.1. You will get 0.109 per unit. Over. Mm. Next is 10. 10 and 13. A three-phase synchronous generator is to be connected into infinite bus. The lamps are connected as shown in the figure for the synchronization. The phase sequence of the bus voltage is R by B and of that incoming is R dash Y dash B dash. So it is found that lamps are becoming dark in the sequence LA, LB, LC. It means that phase sequence of the incoming generator is. So synchronization procedure. What is the synchronization? It says if all bulbs are simultaneously glowing and darkening, then what is the position? So One thing we need to understand is if it is dark or bright, all together has to happen. Then only we can say that phase sequence is same. Otherwise, the phase sequence of the system is opposite. So opposite to infinite burst and its frequency is more than infinite. Opposite to infinite burst, but its frequency is less than the infinite. So one thing you understood is opposite to infinite burst, and the phase sequence is L A B L B L C. So it is frequency is more than the generator, so becoming dark in the sequence LA LV LC. So it says that normally if the frequency is unmatched, so only two conditions we will to see whenever we are seeing the synchronization. One is the phase sequence, another one is the frequency. What are the conditions? If you are seeing if the all the bulbs together were glowing and means dark positions and bright positions are coming all together, then we can understand that my phase sequence is safe. Okay, and another is that if frequency, the flickering will be there. So if generators more frequency is there, then flickering is more. So one point we can say that is that here the flickering he has told, so we can say that the more than the infinite bus, the frequency of incoming always the same as that of existing. So here how many lamps he has used? Is it a same lamp, that is three lamps simultaneously dark and bright, or one different? No, he has used the first method, that is three lamps are simultaneously dark and bright. So dark and bright, the flickering shall be less, then we can say that frequency is less. If all are simultaneously coming, then it is a current phase sequence, the correct phase sequence. These are the two conditions we need to understand. That's why now we can say that answer is A. Now the next question is 13th. This is also same logic. A non-salient pole, that is cylindrical synchronous generator having synchronous reactance of 0.8 per unit, is supplying 1 per unit power to a unity power factor load at a terminal voltage. So reactance is 0.8, supplying 1 per unit power, terminal voltage is 1.1, neglecting armature resistance. Angle of the voltage behind the synchronous reactance with respect to angle of terminal voltage. So he's asking delta. So what is how we need to calculate? I already showed, that is in the generator the EF is leading to V. So that is why you will get a positive angle delta, positive delta. Hmm. Hmm. What's the answer? So 13. The data is P is equal to 1 per unit, Vt is equal to 1.1 per unit, Xs is equal to 0.8 per unit, Vt is equal to 1. So first of all, I want a current. So P by V cos phi 0.91 will get it. If you know the current, then I can find the E. E at an angle delta, I want it. So if I want magnitude, I can get that one also. E is equal to Vt plus Ia at an angle plus or minus phi, Z at an angle theta. So I'll get the E and also with delta, both the values will get it. Otherwise, rectangular formula, this is the polar formula. If you are using the rectangular formula, that time also you will get the magnitude here, rectangular formula, and delta. Delta is same way, P is equal to EV by X sine delta. So this is the way we will get it. So that's the way we solve the thing here. So just I'm giving 5 minutes time to you. So please, if any doubts, if you are having, please ask. Any doubts? Hmm. Okay, just I'll give 5 minutes break. Only 5 minutes. So Okay. Now we'll move to the DC machine. So DC machines anyway, that is a small points or whatever the topics were coming up, I like this plan. So what are the questions we could see? Just I think 1 and 2 sheets are over automatically, and third sheet is also over. Fourth sheet, till 13 it is over. Now 14 and 15. Hmm. A 15 kilowatt 230 volt DC shunt motor has armature circuit resistance of 0.4 ohms and field circuit resistance of 230 ohms. At no load and rated voltage, the motor runs at 1400 rpm and the line current drawn by the motor is 5 amps. At full load, the motor draws a line current of 70 amps. Neglect armature reaction. The full load speed of the motor in rpm is. So just is asking the motor speed and those calculation. So basically the formula here it lies with the motor speed and calculations are, we need to see that if it is a shunt motor, the relation is straightly we know it. Just take the data. What is the question number? 14. 14 question number. What is the data he has given? It is a 15 kilowatt shunt motor. Basically, first draw the shunt motor. Shunt motor, 230 volts, 15 kilowatt. Armature circuit resistance is 0.4 ohms. And the field circuit is 230. So from here you will get the current, then automatically 230 by 230 1 amp current it will go here. At no load rated voltage, the motor runs at 1400. So for no load speed is 1400. Here always what is the relation with this? N is EB by 5. So in a shunt, phi is normally we keep it as a constant. So here N is directly proportional to EB. Especially here it is a EB. The line current run by the motor is 5 amps. 5 amp 1, that is 4 amps it is coming here. At full load motor draws a line current of 70. The no load is, so first of all you find out the no load one and full load. So that is 230 minus 5 into IA RA 0.4. We'll get the value of 5 into 4, 2 ohms, that is 228. Here it is 230 minus 70 into 0.4. You will get around 202, whatever the voltage, EB, and he has given the no load speed. So N2 by N1 is equal to EB2 by EB1. So if you are taking the no load, this is a no load EMF thing. So what is the equation you will get? 1400 into 202 by 228. You will get 1240. So EB by 5 relation, it goes on. In the series, you can't make it as a 5. It is a current. So depending upon the no load current and full load current, so it will be there. So it depends upon the motor, whichever they are giving up. Again, the no load speed of 230 volts self separately excited DC motor is 1400 rpm. The armature resistance drop and brush drop are neglected. Okay, here any drops have given 0.4 only, no? Nothing. Okay. The field current is kept constant rated value. The torque of the motor. Now he has given the torque. So what is the formula for the torque? What is the formula? So torque is equal to V into I by. So Suppose if you are not remembered any of the formulas, no problem. P into torque into speed is a P. P is equal to V into I. That's the links you need to make up. So no load speed, that is the speed he has given 1400, that is 2 pi and by 60 into torque is equal to, and current is 8 and voltage is 230. Over. Number is gone. So torque is equal to 12.5. So fourth page is also over. Now fifth page gone. Now 23rd question. What is that? A DC shunt generator delivers 45 amps terminal voltage. The armature and shunt field resistance. The stray losses are 375. The percentage efficiency of the DC generator. So now we need to understand the stray losses and what are the efficiency equations. So first of all, what are the formulas are there? So output is equal to input minus losses. So losses, basically when you're talking about constant losses, variable losses. Variable losses basically copper, but constant losses are iron plus shunt. Iron plus shunt. So when you're talking about the stray load losses means copper losses, series and other whatever the load, and these are variable losses. So variable losses means copper losses and also your load friction and windage losses. It is, sorry, iron losses and friction and windage also will take it as a constant. So iron losses, shunt losses, friction and windage. So when we are seeing this, the equation, the shunt field he has given, stray load losses he has given. The efficiency when you're talking about the formula here is, yeah, we need to finalize what is the generator. So output is 220 into 45. That already we can take into. So first step is, what is the question number? This is 23rd. 23rd question number, output. First of all, output is 220 into 45. Okay, 220 into 45, you can take it as a, what is the point he has given? We'll draw the diagram, then you will get a clarity. 220 volts, 45. What are the impedances? This is 44 ohms. This is 0.01 ohm. Shunt generator 45 amps it generates. 44 means here it is 5 amps. Here it is, you are getting 40 amps. And stray losses are 375 watts. So total copper losses when you're talking about 5 square into 44 plus 50 square into 50. Sorry, this is 50. 50 square into 0.01, because this 50 it will go here and load it will come. Yes, 0.01. So sorry for the blender. Okay. So this is 100 plus 25, 1125. Other losses are stray load losses. Stray load losses here is told that 275 watts. So total losses when you're talking about 1125 plus 375. Might be it is 1500 na? Yes, 1500 watts. And the output anyway we know it, 220 into 45, that is 99. So efficiency is 99 by 9900 plus 1500, then you will get 86.84%. Again, 28th question is also same way, whatever way we did it. 120 volt shunt motor takes 2 amps at no load and it takes 7 amps at full load while running at 1200. So full load speed is 1200. Armature resistance is given, shunt field resistance 240. So then the no load speed. So same logic. So N is direct proportional to EB by F shunt motor. Anyway, the flux is constant shunt, so that the no load speed is NA directly proportional to EB. The no load current is 2 amps, so that 120 minus 2 amps. So how much is the current it takes? Field 240. 120 volts by 240 is 1 by 2. 0.5 takes, so 1.5. So 1.5 into 0.8 plus minus 120 minus this one. So you will get EB. Same full load current 7 amps minus 0.5, so 6.5 into 0.8, 120 minus this, so that you will get, so one full load speed already has given 1200. So same logic. 24, 120 volts, 240 ohms, 0.8 ohms. Here it is taking 2 and 7. So this is 0.5 takes and it is 1.5 or 6.5. So 120 minus 1.5 into 0.8, 120 minus 6.5 into 0.8. No load is 1200. Sorry, full load is 1200. This is x is equal to 7. Now 29, the series shunt has come and series has also. So series question. What is the question it speaks about? 200 volts DC series motor when operating from rated voltage while driving a certain load draws 10 amps and runs at 1000 rpm. The total series resistance is 1 ohm. The magnetic circuit is assumed to be linear. So linear means direct proportional to IA. So, and the at supply voltage, the low torque is increased by 44%. So low torque. So when I'm coming in this equation point of view, we will see what are the equations they are giving up. So especially the series when you're talking up, 29 series motor. So draw the diagram. Always only two terms. 200 volt series motor operating at rated voltage driving a certain load draws 10 amps and runs at 1000 rpm. The total series resistance is 1 ohm. Total 1 ohm. The magnetic circuit is assumed to be linear. At the same supply voltage, the low torque is increased by. So here is a square relation. So here when you are seeing it, what is EB1? EB1 is equal to V minus IA into total 1. So V is 200 minus 10 into 1. So you will get 190 volts and the speed is 1000 rpm. So low torque increased by 44%. So we need to understand T2 by T1 is 1.44. T1 by T1 is equal to IA2 by 10 whole square. So IA is, you will get 1.2 into 10. So that is, you will get 12 amps. 12 amps you will get. In this 12 amps, if you are doing it 200 minus 12, you will get 188 volts. So same equation. N is directly proportional to EB by 5. So N2 by N1 is equal to EB2 by EB1 into IA1 by IA2. Here it is not constant. So N2 I need to find 1000 is equal to 188 by 190 into 10 by 12. This N2 is 825 RPM. So 33 question, 33rd question. A 220 volt DC shunt motor takes 3 amps at no load, draws 25 amps at running at full load speed. The armature and shunt resistance are this one, the no load speed. So shunt motor, the flux is constant, and we can see that how it is are coming up. So same logic. Sorry. To 20 volts, 3 amps or 25 amps, running at full speed 1500. Armature and shunt resistance 0.5. This is 220 ohms. This is taking 1 amp. Either it is 2 amps or it is having 24 amps. So full load is 1500. Asking for no load speed. So N naught. So EB naught is 220 minus 2 into 0.51. So 219. EB full is 220 minus 12, that is 208 volts. So N2 by N1 is equal to EB2 by EB1. So full load, if you are talking about N2, 1500, EB2 full load is 208, this is 219, then speed. So you will get 1579.33. So by seeing all these things, so I'm taking mark all the questions which have been solved. So 8 pages, all the 34 questions we have been seen, and one session if you are having any of the point, so I'll be there for 3 minutes, you can chat. So you can chat there. Thank you Aditi, thank you Ashwin. So you are giving replies, and especially so Abhishek, whoever has been listening later also, just want to thank you. And if any of the doubts you are having, so You can contact the Vidyalankar team. They can approach. They can make a channel to approach us, and we can pen. And one suggestion is that just this type of the sessions we are keeping to make more confident, and especially we are making that if any doubt or anytime, so they will share our contact number and you can contact us, and never ever depress, never ever worry about what are the concepts you are not knowing. And in this period, don't learn the new concepts and practice more, and so that whatever you know you can sharpen whatever the logics you know it. If any doubts you are having, you can contact your friends always and your teachers, and especially us, you can reach, so we can give you the right answers and the right way of approaches. So thankful you and all the best. So never ever discourage, try your level best, always it gives the success, don't worry. Everyone, whoever is writing, everyone by their own preparation only, they did not come from the heaven. So thank you.